Hey guys, it's me, Miss Doolittle. Just want to let you know that today you're going to learn how to figure out if something's linear or non-linear. And you're going to learn it from three different methods. One from a table, one from a graph, and one from an equation. Alright, let's figure this out together. Alright, so here's a reference sheet for you. Helpful checklist to determine if you have a linear function. This is something you're going to need to study. Even something you might have to memorize. As you can see right here is teaching you how to do it from a graph. Here is from ordered pairs. Over here is a table, and last is from an equation. This is something you're going to need to read and study. Alright, hey everyone. So today we're going to talk about the difference between being linear and non-linear. We're going to see it from a graph. This is the first one we're going to look at. So when I'm talking about a linear function, I know it has to be constant. It has to be constant. So let's watch. My y values are changing by plus 2. From 0 to 2, it's plus 2. From 2 to 4, it's plus 2. From 4 to 6, again, plus 2. 6 to 8 is plus 2. And 8 to 10 is plus 2. So that's a constant rate of change. Now let's watch my x. Plus 1. From 0 to 1 is plus 1. Plus 1. Plus 1. Plus 1. Plus 1. This is constant. So it is a linear function. Now if I look over here, this one's non-linear. And I know non-linears are going to be not constant. And let's check this out. From negative 1 to 0, well, that's plus 1. But from 0 to negative 1, that's minus 1. And from negative 4 to negative 3, that's minus 3. So as I can see, that is not constant. At first, I'm adding 1, then I'm subtracting 1, then I'm subtracting 3. That's not the same. That's not constant. Over here is plus 1, plus 1, plus 1. But since that was non-constant in my y, that's going to be non-linear. All right. All right, the second one we're going to talk about is seeing something linear or non-linear from a graph. If I look at my first one, which is over here, the linear functions, check out all of these linear functions. Look, all of them are making lines, well, straight lines. As you can see, the first one is a completely straight line. The second one's a straight line, and the third one's a straight line. So since they're straight lines, I'm going to consider them linear lines. If we look over here in the nonlinear section, all of these are curves. Curves. Or even in this one that it doesn't curve, it's two linear lines. It's not straight or a constant rate of change the entire time. So it's considered nonlinear. So again, let's look at the first one. These are straight line, straight line, straight line. And then if we go over here to the nonlinear, curve, curve, and even though these are straight, it's not constantly straight the entire time. Okay, so the last one we're going to talk about today is from an equation. As you can see again, I separated it as linear and nonlinear. Before you can do this, you really do need to memorize the reasons why something's linear and nonlinear. As you can see here in the first example, it says x and y both have an exponent of 1. Also, the second thing you need to check for is x and y are not multiplied together. And the last thing you need to check for is x and y do not appear in the denominator, exponents, or the radical sign. So if I look at this first one, I'm kind of just going to go through the checklist. Look, they both technically have an exponent of 1. The one's invisible, we don't really see it there, but we know it has an exponent of 1. If I check all three of them, all the x and y's only have an exponent of 1. So they pass that. The second thing I need to look for is if x and y are multiplied together. So they would be right next to each other. If I look in this first example here, they're separated by an addition sign. This one doesn't even have y, so I know they're not multiplied together. And the last one over here is y, and here's x. Completely separate from each other, so they're not being multiplied together. The last thing I'm looking for is x and y do not appear in the denominator as exponents or in a radical symbol. Again, if I look at the first one, second one, or third one, I can say that's true. I don't see any of them in the bottom of a fraction. I don't see any of them as an exponent, and I definitely don't see any radical symbols. And if you forget what a radical symbol is, it looks something like that. Okay, so I know all of those are linear. If I come over here to my nonlinear section, well, the first one I know is wrong because check this out. X has an exponent other than 1. It's x squared. So that means it's nonlinear. In the second example, I know this is nonlinear because look, y is in the denominator. It tells me x or y cannot be in the denominator or the bottom of the fraction. So this one's nonlinear. And the last one I can see is nonlinear because check this out. X and y are being multiplied together. That's not okay. So I know that this is a nonlinear equation. All right, if you need any extra help or anything like that, please come and see me.